have you ever stopped and wondered what is actually happening inside a tool like ChatGPT? I mean, how does an AI go from a simple prompt to generating a whole story or an image or even music? Well, today, we're going to pull back the curtain on the one piece of technology that's really at the heart of all of it. It's called the transformer. And no, it's not just another buzzword. It is the fundamental architecture that has unlocked these incredible abilities we're seeing everywhere in AI right now. You can think of it as the engine driving this whole revolution. So how do we get from a few words to a complex story? We're going to break it all down. First, we'll uncover the magic behind modern AI. Then we'll see how language gets turned into math. After that, we'll dive into how these models think, figure out their surprisingly simple goal, and finally, see how it all snaps together to create an actual conversation. Okay, so let's start with an acronym we've all heard a million times by now, GPT. Turns out, the answer to what makes it all tick is hiding right there in its name. So GPT stands for Generative Pre-trained Transformer. Generative is pretty straightforward. It creates new stuff. Pre-trained tells us it did its homework, learning from a truly massive library of data. But the letter we really care about today, the part that changed the entire game, is that T for transformer. That's the core invention we're here to unpack. And this architecture is, well, it's incredibly flexible. It's not just for chatbots. The exact same fundamental idea, the transformer model, is behind image generators like DALL-E, tools that synthesize audio, and even those super advanced language translation services. But here's the wild part. For all this complexity, for all these amazing applications, the ultimate goal of these huge language models is ridiculously simple. Everything they do, all the billions of calculations, it all boils down to just one thing: predicting the most likely next word in a sentence. That's it. So, how on earth does a machine even start to predict a word? Well, first, it has to translate our very human language into the only language it truly understands: mathematics. This translation happens in 3 basic steps. First, you take the input text and break it down into smaller bits called tokens. Think of them as words or sometimes even parts of words. Then, each and every one of those tokens gets converted into a long, long list of numbers. We call this a vector, and this whole critical step is known as embedding. Now, a word embedding isn't just a random string of numbers. Oh no. It's a very carefully crafted vector that actually captures the meaning and the context of a word. You can imagine each word as a single point plotted on a massive, multidimensional map of meaning. And what's so incredible about this map is that the directions actually have meaning. For instance, here's the classic example. If you take the vector for the word king, subtract the vector for man, and then add the vector for woman, you land almost exactly on the vector for queen. This was a huge breakthrough. It proved that our language has a kind of geometric structure that computers can actually learn and navigate. And these relationships can get surprisingly deep and, well, kind of funny. Check this one out. In some models, if you do the math for Germany minus Japan plus sushi, you end up right near the vector for sausage. The model just learns these cultural connections entirely from the data it reads. And just to give you a sense of scale, we are not talking about a simple 3D space like we're used to. A single word vector in a model like GPT-3 has over 12,000 dimensions. It's a space with a complexity that's almost impossible for us to even visualize, and that's what allows it to capture so much nuance. Okay, so all our words are now points in this mind-bogglingly complex space. Now the transformer can begin its real work, figuring out how all of these words relate to each other in a sentence. This is all about understanding context. Just think about the word model, right? It could mean a machine learning model, or it could mean a runway model. The meaning depends completely on the other words around it. So how does a machine know which one you're talking about? That's the exact problem the transformer was built to solve. The transformer solves this with a really clever 2-step process. First, in a stage called attention, it basically lets every word talk to every other word in the sentence. They all look at each other and decide which other words are most important for figuring out their own meaning. Then, after all that communication, it moves to a feed-forward step, where each word does some deep thinking on its own now that it's armed with all that fresh context. And it doesn't just do this once. This whole 2-step process gets repeated over and over, refining the meaning of every word with each pass. So, after all of that incredibly complex internal dialogue and processing, we finally get to the model's one and only goal. The whole point of that entire network is to produce one final, super context-rich vector at the very end of the sentence. This one vector has soaked up all the important information it needs to make the best possible guess for what single word should come next. But that final vector is still just a list of raw scores. You can think of them as the model's internal, unfiltered thoughts. To make them useful, they get passed through a final mathematical step called softmax. Softmax is basically a translator. It takes those raw scores and turns them into a nice, clean list of probabilities, a percentage chance for every single word it knows, telling us how likely each one is to be the correct next word. Now here's where we get to have some fun. We can actually control how the model picks from that list using a setting called temperature. If you set the temperature low, the model becomes very conservative. It'll almost always just pick the single most probable word, like you see with this one really tall bar. This leads to very predictable, very safe text. But if you turn the temperature up, the probabilities start to flatten out. This gives some of the less likely words a real fighting chance of being picked. This is what allows the model to be more creative, more surprising, but it also increases the risk that it might say something totally random that doesn't make any sense. Okay, so we've gone from words to numbers, processed them for context, and made a prediction for one single word. How does that turn into a whole conversation? This is where the real magic happens, and it's in a simple but incredibly powerful process, the generative loop. The model predicts one word. It chooses one from the probability list. It then tacks that new word onto the end of the text. And then, this is the crucial part, it takes this new, slightly longer sentence and feeds the entire thing right back into the machine to predict the next word. So that's the big secrets. What feels like a deep, sophisticated conversation is actually just this ridiculously fast, one-word-at-a-time prediction loop running over and over again. Repeating this simple process thousands of times is what creates everything from a one-sentence answer to an entire novel. And that leaves us with a pretty fascinating question to chew on. If these incredibly powerful models are built on such a simple foundation, literally just predicting the next word in a sequence, what does that really tell us about the nature of intelligence itself? And where do you draw the line between just being a really, really good predictor and having genuine understanding?